It's been one of those weeks for like a month. This week's theme is basically security and projects. I'll update you on some projects. But mostly it's about security. But it's going to be a little different. But also, like, if you got a home lab, you should update yesterday all of your stuff. In fact, you maybe should like unplug it, take it offline for a while. Because, whoo boy, it's dark out there and we may die. You may be noticing this is actually Falcon Northwest's Falcon Fuel Coffee. I've got a 9950X 3D2 and it's from Falcon Northwest, and we're doing a review, but I'm also going to give it away, so stay tuned for that on the main channel. Look for that. There's a couple gotchas there, but the mission to acquire more 9950X 3D2 CPUs for testing was successful. I'm getting ahead of myself, though. This is more project talk. Let's talk security. This older article, look, it's from April 12th. I'm behind the times. So we may be living through the most consequential 100 days in cyber history almost nobody has noticed. Oh, this is just the beginning. It is about to get much worse. In fact, it has gotten much worse. This details all of this stuff. It's like the first 4 months of 2026 have produced a sequence of cyber incidents that, if any one of them had landed in 2014 or 2017, would have dominated the news cycle for a week. I'm still talking about the OPM hack from a long time ago. And all of these things are kind of related. But I have to lay this out there because not a lot of people pick up on this and how incredibly important it is and how compromised our machines already are in ways that you might not realize. But let me come back to that. Copy fail. This is the one. 732-byte Python script roots every Linux distribution shipped since 2017. It doesn't have to be Python. Some people have done other code not in Python. This is real. This is legit bananas. This is like, if it could be a 10.1 or a 10.5 on the severity scale, it should be a 10.1 or a 10.5. This has also caught a lot of distros flat-footed, meaning that there aren't patches or your only option is to reboot and update your kernel, but some distros don't even have an updated kernel, or at least they didn't have an updated kernel. So it has been a mad dash since Wednesday of this week to try to deal with that. And to give you an idea of how insanely bad this is, like if you're using WordPress, I always pick on WordPress, and somebody had access to your WordPress, like they can run things as a PHP script, you know, on your web hosting. And Python is usually available on basically all web hosting. Well, from this relatively innocent, oops, I've got a bad plugin in Python, they can root the entire box. Very bad. Very extra mega bad. There are some mitigations with SE Linux, and it's not perfectly universal, but it is substantially universal. And this is a 4-alarm fire. This is also it's a problem in the cryptographic routines. One of the cryptographic routines, there's some, like, you can disable it. It's like it's not going to affect LUKS or IPsec, but it may affect OpenSSL with the AF-ALG algorithm enabled, and like this kind of thing. Like, I want you in the back of your mind anytime you see this kind of thing. This has endured since 2017. It's been there a long time. A very subtle bug. Crypto algorithms are a great place to hide deliberately added weaknesses. And you might think, who would do that? There is a preponderance of evidence suggests that an intelligence service has been caught with their hand in the cookie jar to do with dual elliptic curve encryption, which was the root cause, IMHO, of the OPM hack so many years ago. You see, there are a lot of intelligence services out there, ours, but also not ours, and also really not ours, and then like frenemies not ours. So there's a lot of players in this game. There are a lot of really smart. Everybody goes cross-eyed when you look at crypto code. Crypto code is just like, it takes a certain kind of mind that has been trained for a certain amount of time to really, and so this is the perfect place for an intelligence service to introduce this kind of a weakness, and it would go undetected for a very, very long time. We almost had this level of a severity issue introduced with SSH. That was only a couple of years ago. So this kind of issue can be a subtle issue, but then this is great for an intelligence service because they can escalate their access, they can remain undetected. If your motive is not to deploy ransomware or just wreck everything, this kind of an exploit is fantastic because you can lurk and be undetected for a very, very long time, especially if you've been able to compromise the networking gear a little bit through other means, or even out-of-band access, compromise out-of-band access through other means. This is fantastic. But it's very bad for you and me. Very extra mega bad. Also, cPanel. cPanel and WHM. cPanel is the most expensive, and they keep just ratcheting the price up. cPanel is hosting software where, like, if you want to take a server and slice it up reasonably into 100 slices and have all of the bookkeeping and accounting stuff handled for you in a nice GUI, and you can just, like, turnkey give somebody a little slice of that and still have reasonable security. Like, cPanel does a lot of stuff. It gives you a lot of options for, like, jailing the file system and, you know, running quotas and making sure that one compromised WordPress host doesn't chew up all the CPU on the whole box. Like, cPanel is genuinely useful software that has a long and storied history. And it's trash. I'm sorry. For the money that they charge, it is astonishingly disappointing. This CVE is very bad. It's remote root. It's unauthenticated remote root. It is trivially exploitable. So if you have a cPanel server and you haven't patched, chances are it's been compromised. Even if you have patched, it is probably no longer supportable, or like it's probably like I don't have any confidence that their stuff works. They have a script on their website for indications of compromise, but for the session files that a patched version of cPanel writes, the indicators of compromise thing will tell you that you have been compromised when you have not. The session file exists, but that's just because the cPanel service is running and something connected to it. It is not actually an indication that cPanel was successfully compromised. It's just that someone was trying to run the successful exploit against you. The actual way to check if your cPanel is secure is to actually run the exploit against it, which there is a GitHub repository, and you can just go run it and see if your cPanel, but like if you like, you can also just turn off the cPanel services. Their article is also really annoying because it tells you that you need to clear the sessions. It doesn't tell you how to clear the sessions if you didn't already know, which is, you know, like everybody knows, but not really. Like that's a really, like that is poorly written article. The other thing with that is that it doesn't tell you. It tells you how to stop the cPanel services in case you can't patch right now. But that is a temporary solution because there's another cPanel service that will auto restart services that are stopped. And it doesn't mention that or tell you how to do that. And so this has been extremely badly handled by cPanel, in my opinion. And it is probably because, you know, they had reports of it happening as early as February 23rd, 2026, prior to the vulnerability's public disclosure. And Watchtower is the one that has published a technical analysis and a proof of concept exploit. So check out Watchtower's GitHub link. And yeah, February 23rd, 2026, again, is a giant vote with your wallet. cPanel is dead to me because for the amount of money that they are generating, they should have the best of the best security team running this. And they don't. I don't know why, and we'll talk about that in a second. But there is also CISA adds actively exploited ConnectWise and Windows flaws to KEV. So there are 8.4 path traversal vulnerability in ConnectWise. A lot of people use ConnectWise. Protection mechanism failure in Windows shell that could allow an unauthorized attacker to perform spoofing over a network. Yeah, all this stuff is fixed in April 2026. So Microsoft is also having a bad time. There is also a critical authentication bypass vulnerability that multiple threat actors have used earlier this month that I think is mentioned in the other one, but it's also part of the Storm 1175 attacks deploying ransomware. Like this is it's just Carrington event level security problems. And because I mentioned the OPM hack, there's also this article is about Fast16 malware. This one's 16 years old. You don't have to worry about this one. But this is malware. The headline is Pre-Stuxnet cyber sabotage targeting LS Dyna, PKPM, and Mohit engineering software. So this is more like the first scenario that I mentioned, where it's an intelligence services dream to have this kind of a thing and this kind of access. And so this was malware that was designed to sabotage your nuclear calculations. Like if you're running certain pieces of software to just do nuclear simulation or like physics and chemistry simulation that compiled with the Intel C or C++ compiler, this is designed to introduce very small, subtle errors in your floating point calculations. And it went undetected for like 15 or 16 years. This is, if you're not familiar with what Stuxnet is, Stuxnet was malware that got loaded onto the physical enrichment like cyclotrons or the equipment that Iran was using to enrich nuclear material. And the output of the sensors, what it was sending, the output of the machinery, what it was sending from, like, as if it was reading its sensors to the control system, was wildly different than reality, which resulted in a catastrophic setback. And so it's like, woo, Iran. But we should all be scared about this kind of thing because the faulty brittleness that was used there could be used by other folks that are clever and do things with, like, your technology can be co-opted against you in ways that you don't understand and in very subtle ways. And so that is what happened with this as well. And some of this may stem from innocent bugs, but then you introduce like deliberate weaknesses. And this one is not really all that stealthy. Like somebody had actually uploaded this to VirusTotal 1 million years ago, and VirusTotal didn't like, what is this? What sort of malware is this? It's like the security implications of FAST16 are profound and far-reaching. The malware's ability to propagate across networks and infect multiple systems means that even redundant verification of calculations can be compromised. Its stealth and specificity allowed it to remain undetected for years, as evidenced by its near zero detection rate on VirusTotal, even a decade after being uploaded. Yeah. AI doomers are doing a victory lap right now because a lot of this, it stems from AI tools finding vulnerabilities in software and bad people weaponizing the things that have been found more quickly than human beings can keep up. Now, come back to cPanel. cPanel has a really amazing profit margin. It's incredible. It's incredible how much they've raised the prices over the last couple of years. And because they're a dominant player in the market, the margins are good and the volume is good. They can afford to hire security people at the bleeding edge using the tool to do anything. Like, I'm sure that if they called Anthropic and said, hey, can we get access to Mythos to help us? Anthropic totally would help them do that. If you say that we must not build AI, period, to do this, I have some bad news for you. Because remember the other intelligence service and the other intelligence service and like the frenemy intelligence service? They're going to do it. And so it's like, we should stick to bows and arrows because the flint musket is too powerful and it changes the balance of power. It's like, yeah, I don't know. I'm kind of with Teddy Roosevelt on this one. Walk softly and carry a big stick. Like we all kind of need big sticks for this. And I'm sure that some of you will try to form a coherent argument about, why AI should not. This is the worst of AI. The reality is that the number of software bugs here are finite. And building an IMHO, building an adversarial AI, like it is within building a small AI for millions or tens of millions of dollars, as opposed to the billions of dollars that are probably being spent by intelligence services to look for these weaknesses and counteract them, is within the realm of possibility. Reasonable people, that's probably going to be you and me. Like this is, it has to be this way, are going to build the tooling to find these kinds of things. There are not an infinite number of software bugs. You know what is infinite? Human stupidity. These tools finding these bugs quickly, it is going to be a dark period. I hope the dark period doesn't send us back to the Stone Age. It probably won't. By preponderance of evidence, it almost certainly won't. But these tools will help us find these bugs and harden against these kinds of things. Copy fail, the page is sort of doom and gloom, but there are, we lucked out with layers of hardening in some scenarios, like with SE Linux. It was not, SE Linux did not do the mitigations, including SE Linux, were not comprehensive and not perfect, but not bad. I was also kind of surprised in the kernel live patching thing. Like, I was doing some experiments with kernel live patching, and something went wrong, and I ended up getting a kernel oops trying to do a live patch. And so it was probably just moving at the speed of light and breaking things. I'm really not sure. And so, like, if you look at the OPM hack thing, the dual elliptic curve encryption weakness, in the context of having a tool that can help you lint your implementation of the cryptography in the same way that code linting is like you must follow these spacing rules and these padding rules and this kind of thing, a linter to help you build tests, meaningful tests, and run tests, and say, hey, you've literally implemented the reference implementation of dual elliptic curve without coming up with your own random numbers. We should not do that. Is possible when you have an agent helping you do that. It's not that you turn your brain off and let the AI do things. Oh, Lord, no. That is going to end catastrophically. Like, there's going to be the things that are happening where companies are doing that, where it's like, oh, look, one person can do the work of 10 developers. Those companies are not long for this world. AI needs people. When you have one person trying to do that much work, it is too much cognitive load for one person, first. Second, because it is too much cognitive load for one person, they will end up deferring the cognition to the AI, and it's going to produce very bad output. But if you treat it like a helper that can go do all the unfun things, like building the unit tests to try to find these kinds of things, and lint over your code to eliminate these issues, it is very good at that, as evidenced by folks using tools that are available to them, up to, not necessarily including Mythos, to find all of these vulnerabilities. Responsible disclosure would be nice if it were a little better. The Linux kernel is shedding drivers for old hardware and this kind of thing to try to shore up some of the security. But this is also why it is critically imperative that you post all of your stuff. And I would also highly recommend taking your stuff off of the internet directly, or if you can directly access it over the internet, and instead switch to something like Tailscale or a zero trust reverse proxy. I think we're almost to a point. We're transitioning now into projects. I think we're almost to a point where I can actually do a web-based zero trust proxy. So I think it's called Pomeranium. Is a reasonable implementation of what I have in mind. But I've always wanted to build a web landing page that is a very low surface area for attack. And you land at the web page and you log in, and then you have access to resources behind the web page. Enterprise has been doing this for a long time. Cisco has some stuff for this. Cisco has some patents on stuff for this. Juniper has some stuff. Also, Juniper fell into the aforementioned AI trap. Just gonna throw that out there. And so that's existed in the enterprise for a long time. What I want to do is have the proxy forward authentication to services. So, like, the F5 load balancer can do this. There's a lot of stuff that can do this. You have forward auth type stuff in the enterprise where the gateway does the authentication, and then it can pass an authentication token to things like Jellyfin or Plex. Well, Plex is probably never going to support this, but we can hack it into Jellyfin. That's no problem, or Nextcloud or anything else. So you land on the low attack surface area secure web page, and then over HTTPS TLS you can access internal services. I was tempted to try to build something like this because we got all the pieces now, all the browser support to be able to do that. And then once you get a session, you've got a secure tunnel to all of your services. So it's like Tailscale, but you don't even need the Tailscale client. And it's not really truly naked on the internet. Like, you can have the little service that's naked on the internet, but you could host that on a $5 a month Linode plan, or your local connection if you have an IP address, or anything really. So there's a thread on the forum that is asking what your ideal setup is, like what you're running for home lab, what you've tripped over, and that sort of thing. The other thing that I'm working on that is Jake. Remember Jake? Jake's on his own. Jake just bought a farm. We're doing a buddy backup series with Jake, and this is really cool because we are both going to store encrypted data sets for the other, but the data set is encrypted in transmission and at rest. His system does not have my decryption key. My system does not have his decryption key. It's the magic of ZFS with with a cameo of Alan Jude from Clara Systems, because Clara are the ones that are Clara and the folks on GitHub for ZFS are the ones doing the work to make this happen. There's a feature of ZFS called zoned. You can create a zoned volume. I think it's volume is the right terminology there. And this has been around for a while, but not all of the plumbing pieces were there to do it. There's still a couple of minor plumbing pieces to do that. If you walk into engineering, Scotty's got a coiled cable running from the warp core over to a console, and it's just laying on the floor, and it's like, guys, isn't this a trip hazard? They just haven't put the conduit in the floor yet. But it is achievable, and it is achievable running like a TrueNAS VM on Proxmox. That's what I'm doing on my end. But zoned storage is actually the better option. So our how-to is going to have option A, nested ZFS storage, which is dumb and you shouldn't do that. But that's what we did in the video. And then option B is zoned, but the software plumbing is not quite there, so we're going to have that hose draped across the engineering room floor. And Tailscale is going to be the networking component of that, but it doesn't have to be the component of that. You can do all sorts of other stuff with that, and that's totally fine. The other project update, as I might have mentioned, 9950X3D2. That's my system here. I'm looking for performance anomalies, and I'm also looking for motherboards that have I've already put the motherboard that I have that has murdered a CPU is now hosting a 9950X3D2. So we'll go and see what happens there. From that project, it turns out that AMD may have surreptitiously limited the speed at which ECC memory will run on 9000 series CPUs. Now, I have a separate video coming out on that. It's going to be in the main channel. You should check that out. But we may need to make some noise in order to ask for an option to turn that off, because why? I get why. There was a rowhammer attack that allows you to flip bits inside of SK Hynix memory, and that happens less when the memory runs at a lower speed. Now, I don't know that that's why they limited it to 5200. That's just a guess. But the problem is that the same sort of AI tooling that will figure out the stuff will also figure out the hashing algorithm for the memory, so that things like rowhammer are more possible, because there's hardware mitigations for a rowhammer style attack that depend on you not knowing exactly how the memory stores things. Lori Wired did a great video on this, and you should check that out. And it explains all of that in detail if you want to see that. Oh, and actually, while I mention that, if you look at some of our really old videos, a long time ago, I said, man, I really wish I could do a video that does justice to this paper that one of the old Unix C guys wrote called Reflections on Trusting Trust. She did the video on that not long ago, well, a little ways ago, and it is incredible. You should check that out, because it ties in with the whole OPM dual elliptic curve. It's like, how do you trust the output of the compiler? But watch that, expand your thinking, and then step back into the larger forest of all of the other stuff that's going on with that and tooling and that sort of stuff. Remember when we took a look at the Hygon CPUs? AMD shared the Zen 1 designs with Hygon, and then Hygon took Zen 1 and modified it, and then it was a lot of fun to side-by-side Zen 1 with the Hygon CPUs, because the Hygon CPUs completely gutted and replaced the random number generator and a lot of the math functions in their version of Zen 1. And so it was AMD Zen 1 CPU for x86, but all of the math stuff was completely redone. And if you look at that with a lens of, then it's like, oh yeah, their intelligence service knows. It's like, do we know that they know? I don't know. I don't know if we know that they know. But it was clear that it's like, oh, if we're going to you trust and run these CPUs with state secrets, we got to be really careful with our floating point numbers, and we got to be really careful with our random number generation and blah, blah, blah. And the OPM hack was definitely hand in the cookie jar, like, we know. We're letting you know that we know what you have done with this dual elliptic curve encryption and Cisco and everything else. And a lot of innocent people were harmed in the crossfire. Reflections on Trusting Trust. Her video explains that very well, and she did a really good job. And it's amazing. See, like, I'm a lowly computer janitor. Like, I'm out here. Like, you'd be surprised at how the scale of janitoring that I'm up to. Like, I don't really, it's like, oh, you get all kinds of free hardware. I don't really, like, the enterprise hardware is fun. A lot of the time it's in the data center. I can't, like, lay hands on it. But, like, one, it's a lot of work. Two, I do it because I genuinely enjoy it and like it and have fun stuff. But, like, behind closed doors, I'd have to do all this. Like, it's all the same stuff anyway. It's just usually they're not super comfortable with cameras there. A time or two, I've gotten to bridge the gap in terms of, like, look at this cool giant enterprise project, or look at this giant, whatever. But most of the time, and so I'm doing janitorial level stuff and this. She's doing this and actual real honest to God computer science, which is genuinely impressive. So you should go check out those things and see how those goes for various projects. But our 9950X3D2 stuff with the ECC thing was also a little bit of a surprise. And I get why AMD is doing it if it's to do with rowhammer and data integrity. But give us an option to turn it off, because we've been running 5600 ECC without any issues in the lab here since time immemorial, and I'm only just now starting to test that on the 9950X3D2. And, like, including correcteds, like, getting a couple correcteds a month is completely reasonable, IMHO. I think on the test system, we've only ever had 2 uncorrecteds, and that system dates back to the 7000 series CPUs, which is pretty good for a system that has 96 gigabytes of memory. Like, that's reasonable. That's a reasonable amount of uncorrected ECC errors in that amount of time. At 5600 on a mere 8-layer PCB. So yeah, that should be fine. Let's see what else this week in projects. We did the ECC bifurcation video where you can add a PCIe controller and get more PCIe lanes. I'm hopeful for Zen 6 that we'll have more PCIe lanes, or at least take faster. Like, maybe we'll get PCIe Gen 6 on Zen 6, and then maybe those PCIe Gen 6 lanes can break out into more slower PCIe Gen 5 lanes. Like, see, this is a missed opportunity, I think, with PCIe Gen 5. Through the chipset, connect the CPU to the chipset, PCIe Gen 5, and then double the lanes in PCIe Gen 4. There's no bandwidth contention. 4 lanes of Gen 5 into the chipset, boom, give me 8 lanes of Gen 4. That makes sense to me. Especially if you were talking about using AM5 as a server-ish board, like a small file server or something like that. You need PCIe lanes to connect external disk shelf controller, fast networking, or whatever. And an AM5 network where it's just taking data off of a spinning Rust hard drive and shoving it onto a 25 gigabit network adapter, AM5 CPU is perfectly reasonable for that. But it's a little bit tricky to do that with only about 24 lanes exposed on most motherboards. And most motherboards don't really give you a lot of slots either. AMD, there was the Asus X570 ProArt, I think, which is X8, X8, X8. That was almost the best server motherboard for the AM4 generation. I'm still running a 5950X on that board as a server, as a backup server, to just host a bunch of hard drives and connect to the network. And it can do 2.5 gigabytes a second. So, yay, projects. Well, I think that's about enough rambling for this one. In case you can't tell, I basically slept at the office this week, helping jockey the level of janitoring that was required because of this. Please don't make it worse. Nervous laughter. It's literally the Ralph meme. I'm in danger. All right. Thanks for hanging out. Thanks for listening to me ramble. And, if you have any questions, engage in the forum. Let's talk. I missed some questions this week because the security stuff was just absolutely overwhelming. But I think when we get to the other side of this, sneaking in this kind of chicanery, especially if we don't trust the cloud models to overlook this kind of chicanery, because I'm sure that somebody somewhere is trying to figure out how to convince a model to ignore certain kinds of bugs. I'm hopeful for the future, as long as folks that know what they're doing are fully motivated to use the tools to close these holes. And I am seeing a lot of that behind the scenes from security researchers and smart people, and it's very encouraging to see. Security researchers are usually super paranoid. Like, the ones that are, like, close to the heartbeat of this kind of stuff, they're employed in such a way that it's hard to get them to come on a video. Anyway, I'm Wendell, this Level 1 Linux. Participate in the forum, ask questions, whatever. I'm signing out. I'll see you there.